Hello. Today I'm going to go through the second day of computational text analysis and talk about three aspects of computational text analysis: topic modeling, mostly just give examples of these. Topic modeling, word embeddings, and using LLMs in programming. So you'll have some example code for each of these, and I'll walk through what's going on. So let's put that up on the screen. Okay, so first, topic modeling. So with topic modeling, it's really a cool idea. There are a few different approaches to it, but the big idea is you want to kind of group topics which are similar to each other. It's similar to content analysis. They're the two approaches that I think are most useful for social scientists are LDA, which is sort of an earlier version, which uses kind of tries to predict which words go together based on which words go together in each topic based on co-occurrence in documents. So which documents are similar based on which words they share, and which words are similar based on which documents they appear in together. So there's another kind of the newer version uses these large language models under the hood. And so I'm going to show you a vanilla version. There are some others that are kind of a little more complex and use, you can load in more data from an LLM, but this is called BERTopic. And the BERTopic software is great. There's a great web page about BERTopic. If you just Google BERTopic, that's really good, really helpful, great examples, as well as kind of explanations for all the different pieces. So yeah, it's really good. For a lot of these, I'm not going to run the actual code today because a lot of them actually take a while. So I've run all of them already, but this is sort of based on from the BERTopic site. Some sort of best practices. So by doing our own clustering algorithm, we can set a minimum clustering size. So one of the issues with BERTopic is it identifies the clusters. So it sort of embeds all of your documents and then it does dimensionality reduction and does clusters based on that. But it can have lots and lots of clusters. And so if you increase the minimum cluster size so that documents only get put in a cluster if there are at least 25 of them, for example, it can give you kind of fewer clusters, which are maybe a little easier to analyze. So that's what's going on there. I also used the KeyBERT inspired representation model. Again, I've not used it very much. It's very cool, but it can help identify more representative terms for each topic is the way that they put it. There are a bunch of different, it's sort of like there's these different pieces that go along go along together in this kind of process for getting topics out the other side, and you can sort of mix and match what pieces are connected. So how does the word embedding work? And then once that happens, what is the model for clustering? And then what's the model for representing, the representative words, especially, or et cetera. So that's the idea. We're going to do the same data from last week. So the subreddit post data, and I'm going to do the politics version. This is has the most posts. That's the reason. So we'll just kind of prep the data similar to what we did last time. And then this is how you, I'll zoom in a little bit more, sorry. This is how you create the topic model. So this is the part that takes a while. In this case, it only took me 43 seconds, so it's not too long. But you use this, so you define the topic model up here, right? So this is where you define it, kind of tell it what you're going to be doing. And then this is where you actually create it. So topics and props or probabilities are the outputs. And then you take this topic model that you defined and run the fit transform method with the data set that you created. So this is the data set. It's just all of the text of the subreddit, the politics subreddit posts. So hopefully that all makes sense to you. It creates this, and then once you've created it, once it gets all of this data, the topic model now has access to things like the get topic frequency. So the BERTopic models by default include a -1 topic. So this is, which is often the largest topic. So yeah, so in this case, right, 2,200 of the posts are in this -1. And that's it's sort of like miscellaneous catch-all, and then each of the others should be a little bit more meaningful. So in this case, they had 44 topics, something like that. So you can visualize them. You can mouse over them. Oh, hold on just a second. I think this is some old data. Give me just a second. Okay, sorry about that. I'm back. This was the wrong data set. I was thinking about doing a different data set, so I've corrected that. There are now 22 topics. The -1, now topic 0 is actually our biggest, and the -1, the miscellaneous one, is the second biggest. So we've updated that, and then here's the intertopic distance map. So these are sort of clusters of topics along to kind of put into 2 dimensions. You can mouse over them and actually see these ones are about Trump and COVID. This one, they're really, this is about maybe debt, so that's more about legislation. That's more about the Supreme Court, it looks like, right? So here's all the topics. Mouse over them. You can also look, there's a bunch of cool visualizations. The BERTopic stuff, it's actually very cool. So here's the top 15 topics with their top 5 words each. So you can sort of visualize, the topic 0 is about COVID, really. Topic 1's about Trump, maybe Republicans. Topic 2 is about the court and abortion. Topic 3 appears like it's mostly about California. Anyway, you get the idea. You can look at, you can look at all of these, and they really help to kind of get an idea of what these things are about. You can look at how they are used over time. So because we have time in this case, right? So we have this date column. So I got all of the dates, made them into a list, and then you can make this topics over time model using the original data set, timestamps, and then this number of bins just says to group the time. So instead of, like, we have up to the second, or maybe millisecond, I don't remember how exact that these timestamps are, but they're really small. And so instead of having it, that exact, you just bin them to 100, for example. And then this is what the visualization looks like. So we could even, it may be helpful. Let's try doing it as smaller. Let's try doing it like as 20 bins. Yeah, it's over just September. So yeah, let's do like 30 bins, like 1 a day, sort of. That'll take just a second. Let's look at what this looks like. Yeah, that's a little bit easier to interpret. So it looks like the COVID vaccine one was higher at the beginning of the month, and then maybe tapered off, etc. So you get the idea. You can see how, maybe at like a monthly granularity, you might see some interesting things going on here. Cool. So that's the idea. There's a whole bunch more visualizations. It's worth checking out. Once I finish this video, I'll go back in and add a link to the BERTopic website, because it's really helpful. The other step, when anytime you're doing topic modeling, I think it's really important to look at the actual data. So we had those, you saw like 5 words for each topic. Not super duper helpful, right? It seems likely that you could be misled by them. So one thing we can do is get the info, get the documents most associated with each topic, and then look at those and make sure we're not getting misled. In this case, what we're going to do, so get document info, that creates a document data frame, which includes a probability that a document belongs to an assigned topic. So then we can group by topic, sort by this probability, and then take the first however many we want. So in this case, I did 20, so the top 20 documents for each topic, right? So that's what this is giving us. And then I'm going to print them just so you can see them. But what you'd probably do is do exactly what I do here. Say here, take this code, copy and paste it right here in line 4, and save top documents.csv. And then you could go through it in Excel and look at all of the top post headlines, post text for each of the topics. And that can really give you a different, hopefully a similar idea, but maybe a little bit different, right? So we can see here for topic 0, here are all the COVID-related ones. It does seem like these are mostly related to COVID, and maybe a little bit more about like COVID mandates, vaccinations. Anyway, so you get the idea. Reading these really can be helpful. So it's like, I guess I would say it's maybe a little bit more like negative. I guess COVID's negative already, but it's sort of like negative approach to understanding COVID, et cetera. And so you go through all of the rest of them, look through the top documents and make sure that you understand. Another, I think, where topic modeling is really good, like these texts were quite short. Something that's a little bit longer can be really helpful. So the subreddit Change My View has fairly long posts. The self-text is long. So I think you have the pieces now. I think if you want to, as an exercise, try and get a few hundred posts from Change My View using some of the code I showed you before, some PRA code, run a topic model on them, and then where the self-text of each post is a document, and then run this same thing, find the topics, and see if you can do a little analysis of kind of the types of posts that occur in Change My View, sort of the topics there. Okay, so that's the first one. The second is word embeddings. So word embeddings are actually part of BERTopic. There's an embedding step that happens. But the idea is that you are creating this sort of multi-dimensional space and then create it with kind of a vector that represents either a document or a word or whatever. And so you're sort of placing the words into this multi-dimensional space based on the words that they appear near to. And so you can imagine that, cat and dog both often appear next to feeding and pet and walk and clean up, right? Like all of these terms that relate to them. And so there would be a similar place along many dimensions in this multi-dimensional space. Along some dimensions they would differ, and those are the dimensions, along which they are different. So we can think of this as a contextualized semantic space. And so there are a few things that we can do. One that I'm going to show you here is thinking about how different communities might think of, have different semantic realities or a different way of thinking about the world or viewing things. I'm going to use, so Laura Nelson has done a lot of great work on topic models and embeddings and their relationship to social science and social science questions. So I'm drawing on her work and directly drawing an example code that she's given. There's a link here. But the data we're looking for is data from r/Purdue and r/IU, Indiana University, I guess is the official one. And so this code is basically all from her. So this tokenize, one of the things in this case, for word2vec, which we'll be using from GenSim, we have to do some tokenizing. We're going to get rid of punctuation and split the words into just a list of words. So we're going to take all of this data, tokenize it, and then we'll have two data sets, Purdue data and IU data. I can show you here. I'll show you really quickly what they look like. So here's Purdue data. It's just a list of the terms. So a list of lists where each set of terms is a comment. And so this is kind of the key idea. We are then going to make GenSim word-to-vec models. So we use GenSim, which is a really great set of libraries and tools for a bunch of computational text analysis approaches. So word-to-vec is one of their models. There's a bunch of parameters here. I explain what they are here. For the most part, you shouldn't have to mess with them. I'm going to use skipgram instead of continuous bag of words. Those are the two big kind of different algorithms that you use. But you could try changing each of those. I'll make a quick note that this is in case the kind of syntax is confusing to you. What this is doing, right? We're going to create two different models, Purdue model and IU model, based on this. Like it runs once for each item in this list. So once for Purdue data, once for IU data. Don't worry too much about the syntax. Hopefully it kind of makes sense, but it's basically creating a tuple where the tuples are the Purdue model and the IU model. They use the same parameters, but one of them uses the Purdue data, one uses IU data. And then we're going to, at the beginning part, this part here, we take those and split them into two variables. So we say the first thing is Purdue model, second is IU model. Okay. And then here's what it actually looks like. So for each word that appears at least 5 times, so that's what this min count is, it will be placed into this multi-dimensional space. This isn't tons of data. Like you really kind of want long text for this is the ideal. A book or something like that, or multiple books. And so I have like a bunch of comments, but it's not tons and tons. And so you'll see there's a few kind of weird things, and it's also Reddit comments, and so they talk about some things a lot and some things not very much. Especially Reddit about Purdue is very different than how do people at Purdue talk to each other, right? It's kind of important distinction is that this is not necessarily saying something about Purdue students and how they see the world, but maybe how they talk about the world when talking about Purdue. Anyway, you get the idea. So this. We can look at individual words. So this is the multidimensional vector for the word study, right? So this is 100 dimensions, and this is sort of, you can think of it as being, they go from 0 to 1 for each dimension. So it's really just turning words into numbers, where those numbers are more similar for similar words. So we can do things like look at which terms are most similar to a given word in both communities. And so the words most similar to studying at Purdue are sleeping and hardest and aspects and 101 and friendship, etc. At IU, they are extracurriculars and stress and limit and miss and haha. Again, it's not always super clear why, some words appear in these. And they can be, kind of skewed by a few outliers if they don't appear a lot. If we look at sports, it's even more kind of confusing. So we see like immigrants and dark and media and modern, whereas at IU, consulting and IB and UD and mentor. So not exactly sure what's going on there, but hopefully you get the idea of what you would do and sort of how you can use these. So that's the idea for your exercise. Here, I'll add a code block. Think of some other things you might want to visualize and see if you can figure out ways to visualize differences between IU and Purdue using that data. Okay. Oh yeah, I guess I'll need to make that data available. Maybe I do. I'll check and make sure. Okay. So the last thing is using LLMs for research. I think this is really, really cool and powerful, and we'll be doing it a lot. You can, instead of training an undergraduate or taking a bunch of time yourself to do things like coding texts, you can work on a prompt to train an LLM to do that. And for many things, it can do a really great job. I give one example that's a little bit silly. So let's say we wanted to identify the different hobbies that people do at each school at IU and Purdue. So we'll use that same data. I used Claude.ai. So you'll have to get an API key. If you want to run this code, you'll have to pay for it. It cost me about $5, maybe a little less even, to to classify these 11,000 comments, which is pretty amazing if you think about it, right? Imagine how much you would pay someone to do it if you had to be the one to classify 11,000 comments. So there's at console.anthropic.com, that's where you can sign up for an API key. You should save it is in anthropiccredentials.py in this directory. You can also get Claude AI's help in generating a prompt. So it's sort of like LLMs all the way down. So I generated this prompt with Claude's help, and that's sort of also it gives you kind of all of the code. You can just be like, okay, now turn that into code. So it's pretty amazing. I changed a few things as I went along. So for example, at the bottom here, one thing I did is I changed it into an F string so that I could just put in the comments and the number of comments right into the code. I also added this example for inputs, and I changed a few of the outputs. So it was doing things like giving commentary. So what I told it in the comments is I wanted just JSON output. And it was still giving some commentary like, sorry, I didn't see any hobbies in this set of texts. And so I added this to the remember only return JSON without anything else. It also sometimes returned multiple entries and multiple hobbies for each entry. Like they don't always match up. I'll show you what I did with the code there. So again, a reminder that you should have this many. I think I ended up doing 10 comments at a time. You should have 10 entries in the JSON output, etc. So overall, it worked really well. I also caught some errors and then just waited and retried. I noticed that for really long text, there's actually for long projects, there's a rate limit per day. You can only get like 1 million tokens, I think. And so if you hit that, you gotta wait. So anyway, I guess a takeaway, you can tell, I ran into problems. It's very cool to program with these because whatever problem you have, you can just sort of like in plain text say, don't do this, do this instead. And it really works pretty well. I found it a little frustrating. It's sort of like working with an undergrad that can't quite get what you want, which is also, also a real part of academia. And so you have to sort of do this iterative process. And in fact, if I was doing this for real, I think I would do like the first 50 or something comments and do sort of an iterative process until I really felt good, just like when you're doing actual content coding, until I really felt good that we were both on the same page about how to do this. So keep adjusting these instructions until it's like, oh yeah, that's exactly the output that I would want for these 50, and then you can feel pretty confident that it can do the rest the way that you want. So okay, you'll see there are a few kind of weird ones with how it interpreted my instructions. And I think it really is. I told it, I wanted to make sure we got some output. I said, focus only on hobbies that are explicitly stated in the comments, but you can be generous in your interpretation of what constitutes a hobby. So you'll see that it was pretty generous. Okay, so here's the next part that I did. This is probably not super necessary. So part of it is, so I turned all of the comments, the .body is the text of the comments, into a list. So now we just have this giant list of comments where each item in the list is a string that represents a comment. And then I grouped them into groups of 10. I played around with this a lot. I tried to do like 50, and it was kind of too much. So what I want Claude to return is a list of the hobbies, or an empty string if there's no hobby. And when it did 50, it would often return a list that was like 49 or 51 or 53 long. It just wasn't getting it right, and I wasn't confident that it was mapping correctly. So when I shortened it to about 10, that worked better. And I'll show you I had to do it even a little bit more error catching than that. I also did this comment batches. So let me show you what this looks like. I'm not positive how much of a difference this made because I did it in conjunction with some of the other changes I made. But if you look at comment batches, like just our first one, I changed it into a dictionary so that it has text and then the text for that comment. And I did that just so that Claude would have a better sense of where one comment ended and the next began and wouldn't get confused by that. I don't know how much of a difference it made, but it seemed like a good idea. Okay, the last thing I think I found was really important was to create a file and write output to the file all the time as you're going along. Because these things are not are stochastic, they do weird things. There were a bunch of errors that I found, and so I wrote out to the file. I'll show you in just a second, and then just started over where I had ended last time. So let me show you how I did that. So I created a file, hobbies.csv, and then I opened it and grabbed all of the hobbies for each line, right? I'll show you how I saved it in a second. Each line is a hobby or an empty string, and then I just counted them at the end. If it doesn't exist, it's just an empty list. If it does exist, we count them. So this is how many we've already processed, basically. So we open that file again, this time for appending. So we're going to add to the bottom of it. And then for each set of each batch of comments, so batch of 10 comments, we add to our iterator for how many comments we've seen so far. As long as that is less than how many we've already gone through, we just continue. So we just skip all the batches we've already done. This part, I think, is correct. I feel like it only wrote out all the batches together, so I don't think it ever actually ran this code. But if we're partway through a batch, then you have to start where you left off. So I'm pretty sure this is correct. But let's say it ended after writing 43 of the comments. Well, the next batch size is going to be up to I is going to be equal to 50, and so you want to start at the fourth item in. So anyway, so that's what this does. Yeah. So you take the hobbies count, and then this is the remainder after you divide by the batch size. Okay. So yeah, 43 divided by 10 is 4 remainder 3, so that'll give you the fourth object. Okay. So then I added a print statement just so I could watch it, because it takes a long time. You want to make sure that it's actually running. And then we get the classifications. So that's right. This is running that script up above, sending it to Claude, getting the classifications for 10 at a time. And then this JSON.loads tries to turn that into a list of current hobbies. Sometimes it's the wrong number. So I check to make sure that the length of that list is not, to make sure it is equal to the length of the batch, right? So however many it was sent, it should have the same in the length of current hobbies. If it's not equal, then I restart. So I set current hobbies equal to an empty list, and then I get them one at a time. It's pretty reliable when you're getting one. So it gets one thing, and then I just grab the first item that gets returned when I'm just, so right, instead of sending 10 strings at a time, it's just sending one string, one comment, and it says, what's the hobby that's in this? And so it'll grab that hobby. If that length is still not 1 for some reason, it should be, because I get the 0th item, then I just turn it into an empty string and add that. So now we have this new list of current hobbies, which was gotten one at a time. And then finally, I take, for each batch, take each hobby and the current hobbies. If it's none, turn it to an empty string. I noticed it was sometimes returning none, sometimes returning an empty string. Again, something that you could maybe fix with the prompt. But that's how I fixed it. And then we write that to our file and write a new line so that the next line is a new hobby. There we go. So, and then we can put it back into the original data frame. So here I opened it up, made a new column called hobby, and had that be our hobbies. Then I saved it. This is also a good idea, right? Now I have this, I have the raw data, now I have this intermediate file. But you can look, so maybe we look at just those that include a hobby, and you definitely want to do this to make sure that it's correct, but there's animal rescue is a hobby. It looks like this is some comment about trying to catch some wild animal that animal control is helping them with. There's somebody who's offering to take photos, so photography is a hobby that's mentioned here. Check if the Humane Society is open, so you could visit the Humane Society. So I guess that's, yeah, this seems reasonable, right? I don't know if I would call seeking therapy for stress management a hobby, but again, this is the sort of thing you would go through and adjust your prompt until you felt like it was catching the things you wanted and not catching the things you didn't. But yeah, let's see how many. I mean, you could even do things like let's look at how many hobbies there are for IU and Purdue. So let's see, df.group by. We want to group by what did we call it? Subreddit probably. Subreddit hobby. Will that work? No. Tally. Is tally a thing? Let's try that. New. Oh, I know what we want to do. That's what we want to do. Okay. Let's filter. So df where df.hobby not equal to empty string, and then we'll group by subreddit. Oh yeah, there we go. I think that's about what we want. So that's a simple, silly thing, but IU, there's 1,345 posts that have a hobby, and Purdue has 1,000. So maybe there's more people doing hobby type things, or really maybe they talk about hobbies more on the IU subreddit. So that's the idea. Hopefully all of this code is at least helpful for you. You can reuse it. Happy to talk more about it with you. All right, thanks.